The proton NMR spectrum for butanoic acid is shown below. Which signal in the spectrum corresponds to the carboxylic acid proton? So we are looking at the signal specifically for this proton. And so to solve this, we need to have an idea of the chemical shift of a carboxylic acid. And so carboxylic acid protons are usually on the high end of the spectrum. And they usually show up anywhere between approximately, say, 10 to 13 ppm. And so ppm is the scale on the bottom, parts per million. So that's measuring the shift from 0. And we often see a peak at 0 for that internal standard. So that tells us that this signal right here that looks like it's somewhere at around 11.5 is that carboxylic acid proton. Okay, so we've answered the problem. We can look at this a little bit more if we want to. So we can go and label all of these signals. I want to point out just one more thing. So for this alkane chain, as you are moving further away from that signal for the carboxylic acid, you're going to see these decreasing. Because what's happening is the closer your protons are to that carboxylic acid, the more de-shielded they will be, which means they will show up farther down on your proton NMR spectrum. And so as you're moving away from that carboxylic acid, we would expect to see those chemical shift values decrease. So this is the pattern that we could see. And once we learn how to analyze everything about this, it will also make sense. We can see that 2 hydrogens because there's 2 hydrogens. 2 hydrogens because, again, there's 2 hydrogens. 3 hydrogens because there's 3 hydrogens on that methyl group.